Okay, so here's our second example for graphing an ellipse. I'm going to go and shrink it and then we'll find all the information that we need. But in order to graph an ellipse, we need all the components. We need to graph and label the vertices, co-vertices, and foci, and the center. And so once we identify all those pieces, we can go ahead and graph. So we're going to find all the information first and then put it on the picture and draw an ellipse. So the center is going to be identified by looking at the shift in the numerator, x and y. And a couple of the basic questions I'm going to ask first: is this a vertical major axis, or is it a horizontal major axis? And we look at where the larger number is. The larger value in this type of shape is going to be our A, which is telling us what our major axis is. So for example, in this problem, the larger number is 169. Well, that is underneath the x. So what this tells us is that because it's underneath the x, it's going to be longer in an x direction. So it's going to be longer this way, and that is horizontal. So I know I'm dealing with a horizontal major axis. So that's something that's important to be able to distinguish. Not so much necessarily when we're given the equation, but definitely going from a description to an equation. And so we know with an ellipse, the A, which is going to be the length of our major axis, or I shouldn't say length, it's going to give us the information. So I know the standard format for an equation is going to be x squared over a squared plus y squared over b squared is equal to 1. And so I know a squared in this example is equal to 169, b squared is equal to 25. So a is equal to 13, and b is equal to 5. And the one thing that I know, I'm going to go ahead and shrink this now, the one thing that I do know is that a hold on one second here, sorry, I had to get the pen here. A is the distance from the center to the vertex. B is the distance from the center to the co-vertex. And looking at this problem, there's no shift in an x or y direction. So here's all the info that I have. My center is 0, 0. Now, from the center, I'm shifting for my vertex. I'm going to shift those 13 units in an x direction. Okay, so basically I'm going to take my x value from the center and I'm going to add and subtract those 13 units, and that's going to give me my vertex points of plus or minus 13, 0. My co-vertex are going to work the same way. B was 5. I got that from this stuff over here. And instead of shifting an x distance, I'm shifting a y distance. And I get plus or minus 5. Now, the other thing I need is the focal points. And the focal points are C. And C is the distance from the center to the focus. So these are my little dashes for dittos, saying the same thing. And so to find any of the values, A, B, or C, I have this formula that I can use, which is a squared minus b squared is equal to c squared. And it's Pythagorean theorem, just manipulated to solve for C, which is a focus. But we could really use it to solve for any missing piece of of A, B, or C. So if I have any two of them, I can find the third one. So the focus we're going to find by plugging in A squared, subtracting B squared, and that's going to equal C squared. So C squared is equal to 144, so C is equal to 12. So I'm going to shift 12 units to the right and to the left. Okay, so I'm going to go ahead and we're going to go ahead and move this stuff, and I am going to zoom in on my graph. I'm going to go ahead and graph this. So I knew my center was at 0, 0. My vertex was at plus or minus 13, 0. My co-vertex, which I use CV, is 0, comma, plus or minus 8. And my focus is at plus or minus 12, 0. This is a 10 by 10 grid. Excuse me. So I'm going to call each one of these guys 2. Okay, so I'm changing the scale to 2. And the first thing I'm going to plot is my center, which is 0. And I know I'm going to shift 13. Well, this is the actual coordinate, but also what tells me is this is the number of units I shift from the center. So I'm going to shift 13 units from the center. So I'm at 0, 0 right now. So we got 2, 4, 6, 8, 10, 12. So it's going to be about, let me recount that. I lost my bearings. It's going to be about right there, right? And that point is 13, 0. I'm going to go 13 back. And 13 back, so that'd be negative 13, 0. And these guys are my vertices. Okay, and since I'm right here, I'm going to plot my focal points. And I know the focus, the coordinates are 12, 0, and negative 12, 0. These guys are right next to them, so it's just I was right here, and I got my focus here and focus there. And last but not least, I'm going to go ahead and graph my covertice, which is 8 up, so 2, 4, 6, 8. And we'll notice here we got 0, negative 8, and 0, 8, and I forgot to label these guys. This was 12, 0, and this is negative 12, 0. And now I'm going to go ahead and, you know what, I really liked purple in the last one, so actually, you know what, no, I got a pinkish color here. So I'm going to go ahead, got a thicker graph, I'm going to go ahead and draw this guy in here. And here is our ellipse, and we can tell that it is definitely, I know that's really thick graph, but it is definitely longer horizontally than it is vertically, and we can see that, so it's squished down, so it's kind of like you're pinching from the top and bottom and pushes the sides out. And this is how we would graph an ellipse. And so now you can see what we've done before with this problem, and you know this video is ending up being 9 minutes, but there's a lot of different things that we need to find. I'll do another example, probably be a word problem where you got to put all the pieces together. But graphing, you just plot the points and draw the shape. Once you get the information, the graphing is not hard.